One that when we have our manufacturing lines, the actual sensing element is actually located away from the actual line. We're actually communicating with it through plastic fiber optic, which is pretty neat. Yeah, that's one. Yeah, you can follow it around and see where it comes back to the actual sensor. That way, you're keeping the sensor out of harm's way, the actual sensing element itself. I don't know. You'd have to get out and look at what these industries are doing. Like we might ask Rosa. I don't know if if some has a bunch of optics, or it'll be an optical sensor. The electric sensor mounted, or y'all got fiber running back to the sensor. So we looked at basic detection. By the way, this is a little one we called it. It's actually through the bank called an optical disruptor. So we're running into these. There's several on the manufacturing line over there. Wherever your transmitter or receiver are mounted. And what happens is that anything, so these things would start off true, right? With no object. And then whatever it's going to sense has to go through the blades. And this is an example. So this is a symbol of a light emitting diode. Most people call them what? And this is a device called a phototransistor. A transistor, guys, is a electronic valve that we can use to control the current. So here we have a pull-up resistor, and this would be what we call it. This is an NPN transistor. And the way we keep it up is you look at this arrow right here, and most people say not pointing in, NPN, but it's actually how it's made with silicon. So this guy right here would have a lot of extra electrons in it, so this would be a negative. This would be a P. It has a lot of what we call holes in it. It would be positive. And then this would be an N, which means it's got a lot of electrons that it can move around. And what we can do is we can control this lead right there. That would be like the handle on your sink. So what do you do with the handle on your sink? Here we're controlling the base lead with light. And the more light you put in it, this thing turns on more, the less light you put into it turns on, turns off. Let's allow this to go up. Well, solar, we don't control things with solar. We use, so when the energy is right on solar cells, producing what it does is it connects this output to 0 volts. So here's my output right here. So we can look at this thing like this. We can look at it as a switch. But the switch is being controlled by light. It'd be like turning your TV on. Or the, of course, this would actually be the unit itself. And then these guys, this resistor here would have to be external. In digital, they should show you how to track those resistors, by the way. They did. There's this inside this box, that would be there. Then you got pin numbers. This lead up here with the C, this is technically called the collector. This one down here is called the emitter. And then this right here, if it was there, would be called the base. So a regular transistor, you'll actually have a lead. Here, the base is actually, the circuit is actually made of light. Figure. Go back and look at that. Thanks for letting me know. Magnetic field. So these guys all sense light, either the presence of light or absence of light. These are magnetic. Fixing that now. Sense presence of a magnetic field. So the two we'll look at, magneto-resistive. A lot of times they get confused with each other. Most people think it's Hall effects, but they work the same thing as a Hall effect, but it's how we have to orient sensors. So this is not electronic, but it's still a position sensor. This is called a reed switch. And it actually has I'll probably have to get one and show it to you on video in this class. Well, the way these things work is that it's got a contact in here. Can you see it? And that is normally open, so there's a little space between there. And what happens is we put a magnet in here, and the magnet's got to be oriented like this. Now, the polarity of the magnet don't make any difference. We could have a south-north or a north-south. And when it gets in close proximity, what happens is these metals right here concentrate the magnetic field. And so this one would take on the south polarity. This would take on the north polarity. And what does unlike magnetic poles do? They attract. So what will this cause to happen? It'll close the contact. And this next slide shows you that. So the north, south, and south. So is the actual reed switch itself will be mounted. It will be. Also, turn this relay by taking, and this is what a lot of PLCs use. They call them relay contacts. Is they'll take this and they'll just wrap wire around it. Of course, it'll be a lot closer than this, right? And then when we come over here and put DC out of this thing, it generates a what? A magnetic field. Now these can turn into little relays. You see, these are used a lot. And I got some of these too. They're integrated circuits. But this is what this PLC uses right here. So this guy's got relay output, but it's so small that I guarantee you it's using these reed switches with a reed switch relays in there. Now we can fake this thing out, and we can use it to appear like it's sensing a magnet. So what they'll do is they'll take a permanent magnet and then they'll mount it behind the reed switch. And then what happens when something metal, and we mount it at a distance, they don't close it, and then when something metal comes through here, then what would happen? It'll concentrate the magnetic field and it'll close the reed switch. So we do this a lot. But a lot of times they'll have an external sensor. My wife so we got one of these things up here, mounted on the window, right? And then of course when they open the window, what happens? Why don't you still use these? It's when the window's actually open. A lot of them we have them at our church. The burger farms was up at our church, but they had dead zones out there. So you literally get back to the church, open those windows up there and climb in and still nobody would even want, because they didn't have motion detector, and then motion detectors also have blind spots too. You know, these guys right here, things go off. So most of them now are RL. In the old days, these were actually hardwired. So what you do is you put your switch in a plastic enclosure. You just actually stick it in a plastic enclosure, and you have another plastic thing you mount on the window, and then of course, after a while, all it takes is a magnet, right? So what would they start doing? What? Just tape a magnet on it. Well, see, it work well. It works off motion detectors work off infrared. Works off infrared light. So yeah. So yeah, and they learn the position before, and then they look for a change. So they did that on Mythbusters one time, where they'd just go really, really slow, and they'd trick them out too. So typical magnetic reed switches, guys. We got these all over our manufacturing line. What's nice about pneumatics? So what damage does? Y'all know what the difference between hydraulics and pneumatics? What's the difference between the two? One uses fluid and one of them uses gas. pressure. Well, what we're doing on most of ours, we're using what we call cylinders, and then we put pressure on one side, and we generate a force. Anybody know the formula for force? Area times pressure. Pressure. We have bigger square inch of the thread of area. The biggest thing is hydraulics, we can generate a lot of force. That's what I'm talking about pneumatics. Is one of the things we like to do is we like to sense the position of these cylinders. Well, in hydraulics, these cylinders are going to be metal. They're usually steel, or real problem. About using pneumatics is we can come up here and actually put a magnet around this piston right here, and then we can use these Hall effect sensors to do what? Sense the position of the actual cylinder. So you'll see a lot of these. They'll just have little things strapped on where we can sense the cylinder. We're using Hall effect or magneto-resistive. If this was hydraulic, we would have to sense the position of the cylinder differently. One way is we could actually mount a tab out here on this thing somewhere, and we could use a limit switch, or we could connect a linear differential transformer into the cylinder and actually do, or we can buy a double rocket cylinder, coming out both sides. LVDT on one side, right? Understand that you use this other one. All the big advantage of hydraulics is that we can generate extreme high pressure. Extreme high pressure. I ran into and I don't know how they did it. I think they had to run air through chillers to get rid of everything with 600 psi. So you use a lot of use hydraulics out there. Your presses are going to be hydraulic. Well, what's the advantage? Another thing about hydraulic fluid is going to be or it's all slippery. You just can't get out of it. Pneumatics, if you have a leak, you might not be able to generate the pressure, but it's not going to kill anybody, right? Plus hydraulics such high pressure that if it springs a leak, a pin leak, and you get it will shoot out. In fact, that's the way we used to take shots when I was in the Navy. They just had air gun. They used to shoot it, but they just do what? They just shoot it through the arm. So I don't still use those good shots, especially in boot camp. That have two these guys on both sides. Don't move, because if you moved, it would cut you. So we use these guys all over the place, reed switches, but we got to have a watt. Magnets make appears and stuff. So these are some examples. So here they have a watt under the hole, that example watt. They have a magnet, and so what happens is when the ball moves across, it's metal, it concentrates the magnetic field, and that's what the Hall effect picks up. By the way, the Hall effect, notice the magnet has perpendicular to the sensor. These will always be wired. Okay. So this is showing you perpendicular. So this is the big difference between a Hall effect horizontal, right? And a Hall effect that's perpendicular, right? To understand the difference. So the magnoresistive occupies the space. So they both do it electronically, but notice on the Hall effect, the actual magnet has to be perpendicular to the sensor itself. So that means if I had a Hall effect sensor like this, then the magnet would have to approach it from this side right here. Magnetoresistive would come from this side over here. So one of the biggest advantages of a magnetoresistive is the amount of it occupies. Right. So one of them would be like looking at a panel from the side, and then flipping it over, looking at the panel from the top. Well, so the Hall effect, we have to come in, we have to expose the magnet perpendicular to the sensor. It's horizontal to the sensor, I guess you'd say. So these guys all over the place, all effect. It wouldn't surprise me. Flattening your trans. So based on the principle that current carrying conductors in light is resistant when exposed to magnetic field, greater and greater distance, and in response to a parallel field, magnetic field, and all of that are the distance. You understand that? Any questions on that? So if you see a question that says a follow, what are you going to say? False. You know. Answer the what? Magnet. Hall effect. Resistive is parallel, right? Y'all understand that? Yes, no. Magnoresistive does not sense metal. It senses a magnetic field. We can make it appear to sense metal by doing what? By providing the magnet. So like the rotor on your car that's sensing, it's the speed of your car. Well, it's made up like this. So it's got a magnet. Then it's got the Hall effect, and then when the gears of your car, when the gears come around, the magnet does what? Concentrates it and picks up the teeth of the gear. But it's not sensing the metal on the gear. It's sensing the concentration of the magnetic field, right? You understand? So Hall effect and magnetoresistive sense magnetic field. It can appear to sense metal, but if they have a magnet built into the sensor, What do we think? So I might require y'all to I think first what I do is the first step. No, first slow down. Yeah, no, we figured they was gonna do that. You know why they did it? Brings up a lot of financial support. Yeah, they got 12, yeah. Yeah. Yeah, because Alabama hadn't really been testing. So, like I said, y'all probably, y'all go ahead and start reading over the discussion on the proximity sensor. It's going to talk about the load current. It's going to be on the first test. I think we just scheduled for people. Right? Or is it? Yeah. So, and if we continue this online session, the way we do classes, we're still going to do that's going to be on. Our hands are we have to follow what the chancellor comes out of the new mandate. We'll figure it out. So we talked about uh, we have to be if we give y'all an eye, we talked about that. So as we start Yeah, tonight we're going to be doing the same thing. I gave the option of the students to do it virtually online if they want to, just like today. I, I, I am new